Welcome to this digital learning material in technical drafting. In this lesson, you will learn the fundamental concepts and tools involved in performing mensuration and calculation, and essential skills in creating precise and professional technical drawings. By the end of this lesson, you are expected to 1. Select appropriate measuring instruments, and 2. Carry out accurate measurements and calculations. Let's begin with the tools commonly used in technical drafting for accurate measurements. First, triangle. It is an instrument used for drawing vertical and oblique lines. You can watch the video provided the link, entitled Watch How to Use the Triangle. Second, triangular scale. A tool used to enlarge or reduce measurements in a fixed ratio on drawing paper. You can watch the video provided the link, entitled Learn How to Use the Triangular Scale. Third, T-square. Used to draw horizontal lines and to guide triangles in creating vertical and diagonal lines. You can watch the video provided the link, entitled Explore the T-square. Fourth, protractor. Used for measuring and setting angles accurately. You can watch the video provided the link, entitled Using the Protractor. In technical drafting, scale allows us to represent objects accurately, whether full size, enlarged, or reduced. The common ratios are as follows. Full size is equal to 1:1, enlarged is equal to 2:1, and 4:1. Reduced is equal to 1:2, and 1:4. Example. In a ratio of 1:1. Or full size. Plot measure 40 millimeters. This means that the scale is actual scale or in full size. Note that 40 millimeters is equal to 4 centimeters, as shown in the given figure. Remember, the drawing remains 40 millimeters or 4 centimeters. Next, we have an example in a ratio of 2:1. Or enlarged scale. Plot the measure 40 millimeters in a ratio 2:1. This means that the scale is double the actual scale or in a large size. Note that 40 millimeters is multiplied by 2. And that is equal to 80 millimeters, as shown in the given figure. Remember, multiply 40 millimeters by 2. And that is equal to 80 millimeters. Now, let's have an example in a ratio of 1:2. Or reduced scale. Plot the measure 40 millimeters in a ratio 1:2. This means that the scale is half the actual scale or in a smaller size. Note that 40 millimeters is divided by 2. And that is equal to 20 millimeters, as shown in the given figure. Remember, divide 40 millimeters by 2. And that is equal to 20 millimeters. To ensure precision in every detail, unit of conversions must be mastered. The basic of conversions are as follows. 1000 millimeters is equal to 100 centimeters. 100 centimeters is equal to 1 meter. 1 meter is equal to 100 centimeters. 100 centimeters is equal to 1000 millimeters. The common conversion of measurements in technical drafting is metric system, wherein 1000 millimeters is equal to 100 centimeters. 100 centimeters is equal to 1 meter. 1 meter is equal to 100 centimeters is equal to 1000 millimeters. In example of actual. Or 1:1. 1 meter is equal to 1000 millimeters. 0.60 meter is equal to 600 millimeters. 0.70 meter is equal to 700 millimeters. In scale 1:100. 1000 millimeters divided by 100 is equal to 10 millimeters or 1 centimeter. 600 millimeters divided by 100 is equal to 6 millimeters or 0.6 cm. 700 millimeters divided by 100 is equal to 7 millimeters or 0.7 cm. Meaning, in 1 meter. Scale 1:100. The 1 meter or 1000 millimeters divided by 100 centimeters is equal to 10 millimeters. That means in 1 meter using scale 1 is to 100. The scaled measurements are 100 times smaller from the actual dimension of the measurements. Next, let's have an example of actual. Or 1 is to 1. 1 meter is equal to 1000 millimeters. 0.60 meter is equal to 600 millimeters. 0.70 meter is equal to 700 millimeters. In scale 1 is to 50. 1000 millimeters divided by 50 is equal to 20 millimeters or 2 centimeters. 600 millimeters divided by 50 is equal to 12 millimeters or 1.2 centimeters. 700 millimeters divided by 50 is equal to 14 millimeters or 1.4 centimeters. Meaning, in 1 meter, scale 1 is to 50. The 1 meter or 1000 millimeters divided by 50 centimeters is equal to 20 millimeters. That means in 1 meter using scale 1 is to 50, the scaled measurements are 50 times smaller from the actual dimension of the measurements. Are we clear? Now that we already have the knowledge, let's check your understanding with a few quick questions. For the directions, read each question carefully. Choose the letter of the best answer. Question number 1. This is a tool which is generally used when reproducing a drawing in an enlarged or reduced form. A. Foot rule. B. Triangular scale. C. Triangles. D. TI square. The correct answer is B. Triangular scale. Question number 2. Which of the following should be used to set properly the drawing paper in the drawing board? A. Triangles. B. Protractor. C. T square. D. L square. The correct answer is C. T square. Question number 3. A drawing scale of 1 is to 100 meter in mm is the same as A. 1 meter is equal to 1 millimeter. B. 1 meter is equal to 10 millimeters. C. 1 meter is equal to 100 millimeters. D. A 1 meter is equal to 1000 millimeters. The correct answer is D. A 1 meter is equal to 1000 millimeters. Question number 4. Which of the following tools is used to set off measurements of angles and arcs that cannot be obtained with triangles? A. Divider. B. Triangular scale. C. Protractor. D. A foot rule. The correct answer is C. Protractor. Last, question number 5. A drawing scale of 1 is to 2 is the same as A. Half size. B. Enlarged. C. Actual size. D. Double the size. The correct answer is A. Half size. Do you get the perfect score? Now, let's review what we've learned today. The tools we use for accurate measurements are triangle, triangular scale, T-square, and protractor. The processes used for accurate conversion calculation in scale ratio and proportion are full size, enlarge, and reduce. We also learned the metric system unit of conversion wherein 1000 millimeters is equal to 100 centimeters, 100 centimeters is equal to 1 meter, and 1 meter is equal to 100 centimeters. 100 centimeters is equal to 1000 millimeters. Today, you have learned the measuring tools used in technical drafting and how to perform scale calculations and unit conversions. Keep practicing your measurement skills, and soon, accuracy will become second nature in your drafting work. Remember, precision is the foundation of every great design.